Right, hey students, and welcome to the next session. Before we begin, first, I hope you're able to hear me. I hope I'm audible so we can begin right away. All right. So, in the last session, we went through a few time complexity problems, and I think I provided one assignment for you guys to try by the end of the last session. That was this. So, before going to further concepts, if this was the assignment given to you, what is the solution? We'll go ahead to our algorithms, that is sorting algorithms, particularly UpNets, and learn all the time complexities of those problems. But before that, what about this? Any answers, guys? What did you come up with as the answer for this? So we have multiple answers. N was one of the answers. I think I gave two assignments. Yes, this was the second assignment. The first assignment is the problem before this. Yes. So I'm directly going to the second assignment first. We'll do the first assignment after this. So if we try this out, if we go through this example, what will be the output? Or what will be the time complexity? Big O of what value? A few of you have said one, sorry, all of you, every answer that I've obtained so far is big O of n. So we'll take this a simple case. We'll take an example, let's say 36 is the number I'm taking. Now in this case, initially I'll take I is 1, S is also 1, um, n is 36, let us assume. First, S is less than equal to 36. Of course, it is less than or equal to 36, true. Now, for those who are saying O of n, you'll understand why it's not big O of n. If there is another answer, it won't be big O of n. And that other answer I'll explain very clearly. Now, in this case, I gets increased by 1 and S equals S plus I. So if I gets increased by 2, S is equal to S plus I. 1 plus 2, S is going to become 3. So S becomes 3, you're printing high once. So high is printed once. Just this is executed once. Now after this, it goes back again, checks S less than equal to N, true. Now when S less than equal to N, again you go here, increase I. I now becomes 3. And you're doing S equals S plus I. S value is 3. 3 plus 3, you're going to make it as 6. Now, after S becomes 6, again, you're printing high twice. So that means this entire while loop is executed 2 times now. Then it goes back again. 6 is still less than equal to n, true. So it then again goes here, increases the I value by 1, that becomes 4. Now S equals S plus I. 6 plus 4, S becomes 10. And it prints high again. It's the same thing done. Now after this, again it goes back, 10 is still less than equal to 36. I increases to 5. 10 plus 5, S becomes 15. After S becomes, we print high again. That means 4 times high is printed on the screen. In other words, this while loop has executed 4 times. Again it goes back here, while S less than equal to N. True, 15 is less than or equal to, so you increase I value again, it becomes 6. And 6 plus 15, pretty much you get 21. It is 6 here. So we have executed this 4 times now. Again, 5th time high gets printed, so I'll just type it on the left side here, 5 times done. And then goes back again, S becomes 7, and 21 plus 7, you'll get something around 38. So that is when It prints again high for the sixth time, and then when it goes again, it stops because 38 is no longer less than or equal to 36. So it has executed 6 times. Pretty much it has executed square root of n times. So if you calculate this for a lower value or a higher value, it becomes somewhere around square root of n as most of the times. Now, when you look at this in a number line, as always, when you look at n and 0, square root of n is much closer to a constant value 0 than it is to n. So you can expect the question to come up with big O of time complexities square root of n itself. Square root of n is a possible time complexity that can come up in some interview questions, because of course anything that comes up in interview questions is something that we do not see in other questions. So you can expect such a question whose time complexity is square root of n. Now again, it all takes one or two examples for you to figure out. Take one or two different numbers to figure out what will be the time complexity. You will get to understand. You don't have to just assume that, hey, it's going to be big O of n. Always know that if it is a complicated question, try it with an example. If it is a simple question which is not complicated, just a simple for loop, you know how many times the for loop executes, you can directly assume what will be the time complexity. But if it's not a direct for loop, if it is while loop with some statements inside it like this, then you need to calculate by yourself, because this is not just a regular for loop. Remember the difference. So anyway, going back to this, let's go for the next question that we had. This is the second question that I gave you guys for assignment as well. Now, what about here? I hope you're all able to understand why the previous one was big of square root of n. If you have any questions regarding that, you can ask me right away. Now, the second question that I'm taking up is this one, which is a triple for loop. Now, what happens over here? The answer to the last question is big of square root of n. The answer of the last question, for those who missed it, it is big of uh, square root of n. So going back to this first problem that we had done earlier, what is the time complexity? So we've got different answers. We'll try this out. So I've got big of n into square root of n. Then I've got one more that is big of, I've got n into square root of n as one of the answers. I've got n into 2 log n as the other answer. Let us try which is more, which is the right one over here. Yes, n2 log n. Perfect. So the first one will execute exactly how many times? N by 2 times. The second one will execute how many times? If you look at this code, it is pretty clear that the first one will execute n by 2 times. I hope that is clear. What about the second one? How many times will this execute? N times or n by 2 times? N times. Now here's the condition. If j was equal to I, instead of j equal to n, if j was equal to I, this answer would be different. Now in our case, j is 1. It's going to execute exactly n by 2 times. Now after this, the next one we have is k gets multiplied by 2 every time. How about this for loop? Is this 2n? No, this is not 2n. Remember, this is not n by 2. Remember our yesterday's classes, guys, don't forget. This is not 2n, this is not n by 2. What do you think happens here? Take an example. Sorry, yeah, the previous case. This is n times, not n by 2. It is n time exactly. This is log n. Remember our yesterday's session. This executes exactly log n times. So what we have here is essentially big O of n by 2 multiplied by big O of n multiplied by big O of log n. Now I can say n by 2 is same as n. Now n into n will give me n square. So I have essentially the first two values as big O of n by 2 into n. Now n by 2 we generally take it up as n itself. If you calculate it separately, this will become big O of, instead of n by 2 into n, this will become n into n into log n base 2. So when you calculate n into n, you're going to get n square log n. So essentially, the worst time complexity of this is somewhere around n square log n. So you can call this as square of n into log n. I'm just writing it over here. So if j equals I, give that a try. I want you to give it a try. Think over what happens. Then again, it requires you to go through the entire code and try it out because we have limited time. I will not be going through it entirely. So I want you all to try it out. We will go back to more time complexity problems afterwards. But before that, I want to go through sorting algorithm first. We'll go through all the other ones after we go through sorting algorithm. Now, to understand sorting algorithm, let's go from one sorting algorithm at a time. Now, we'll begin with bubble sort. Now, if you don't know what bubble sort is, just observe this for a minute. Bubble sort is also called as sinking sort. Just remember, it can also be called as sinking sort. It's not always called as bubble sort. So in interviews, just remember, here's what happens. It takes one element at a time, keeps swapping it with the next element until in each pass, the largest value goes to the final index. In every pass, largest value goes to the final index. This is how it works. So in first pass, the largest value went to the last index. This is just pass one. So last index is done. Now I don't have to include the last index. In the second pass, it compares first and second element. Second is greater than first, swap it. Now compare second and third element. Second is greater than first, so swap it. Now once that is done, compare third and fourth element. Fourth is not greater than third, skip it. Next, go for the next one. It's not greater. Then 7 is greater than 2, then swap it. Then go for the next ones. Again, 7 is greater than 4, so swap it. Once you have swapped this, you've got the last second element as 7. Now in the next part, you don't have to sort the last two elements at all. Just try everything else. First two. First is greater than second, swap it. Then next two. Second value is not greater than second, so don't swap it. Go for the next values. Not greater, don't swap it. Next values. It is greater, so swap it. Then go for the again next values. 6 is greater than 4 again. I is greater than I plus 1 index. So swap it. Now last three indices are sorted. So this can also be called as bubble sort or sinking sort. And here is how it works. Now, in this case, I'm not going to go through entire algorithm to explain this. Guys, please understand. I will not be going through entire algorithm to explain it. I will only show you the code of it. I will only explain it in as basic concept as possible, because for your pseudocode rounds, you don't need to learn everything about sorting algorithms. You need to be able to look at these codes and you need to be able to calculate time complexities. So I will take this example. and I will ask you guys to find out the time complexity. That's it. So take this part, just this one part. If they ask you what is time complexity of bubble sort, just take the code where you perform bubble sort and figure out what will be the time complexity. They will not give you the code. They will assume that you know the code. I have a cheat sheet for you with time complexity of all, I think, of all of these. I'm not sure where it is. I'll just copy that and share it by the end of the session for you. Or you can Google the cheat sheet, you'll get it easily. So anyway, going back to this, I want you guys to figure out what will happen here. This is for bubble sort. Can you let me know what will be the time complexity of this when it is bubble sort? So when it comes to bubble sort, when it comes to sorting algorithms, I will not just go through worst time complexity. I will also try to go through best time complexity as well. I'll also go through best time complexity. Now, here, how many times the swap is executed up to? See, first for loop, let's take first for loop. It executes n times exactly. Not exactly n, it will execute n minus 1 times. So first for loop executes, we'll call it as n minus 1 times. Now second for loop executes n minus I minus 1 times. I may range from 0 to n minus 2. I will range from 0 to n minus 2. So this is the case. So in the last case, it will go only to 0. In the first case, it will go up to n minus 2. So if you calculate this completely, if you try only the inner case, it will go through n minus I minus 1. If you try this out, first time, if the number of elements are, let's say, 5, first time it will go through 4 comparisons. Second time it will go to 3. Third time it will go through 2. Fourth time it will go through 1. So you can say it is 4 plus 3 plus 2 plus 1, somewhere around, let's say, as you can understand this, remember n value is 5. First thing you guys need to know very clearly is that n value is 5. So when you add this back here, it becomes 10. So here you can think of it as 2n in this example. So we'll just consider it as 2n itself, let us assume. I'm just considering it as 2n. I'm not going through any other cases. If you want, take 2 or 3 more examples to try to understand better. Now this becomes big O of n minus 1 into big O of n. Sorry, big O of 2n. Now n minus 1, I can say it is almost equal to n. 2n also I can say it is almost equal to n. Big O of n into big O of n, I'm getting big O of n square. So that is your worst time complexity when it comes to bubble sort. So I'll just write it over here in just a document that we have. So at the end, do you guys want me to copy the entire bubble sort program also? If you just want me to write that complexity, I'll just write the complexity. Or if you want me to copy this entire code, I'll also copy this. Okay, just the basic function part is enough. Again, okay, I'll just do one thing. Just write it as bubble sort code here. If you guys want to go through it, you can. And at the end, I'll write time complexity. Now here, worst time complexity is big O of n power 2 or n square. Now, here's the thing you guys need to know. This is your worst time complexity. Now, what about worst space complexity? How much space is required? If you observe this. What about worst space complexity? It's a constant because you are not creating too many elements here. You're just creating some simple elements like I and J and you're just swapping these. There's not much else. I have a question that is, it's better you put a bubble instead of A. I did not understand Rohit's question. I wasn't able to understand. See, it's not just main. I've put up the entire code, don't worry. The entire C program is there for the implementation. So don't worry about it. So back to this, when it's space complexity, since it's a constant, you can just say worst space complexity is big of 1, because it's not taking like for every element it is creating a new element or something. No new elements are created, you're just swapping. So you can say space complexity is just big of 1, but space complexity is not often asked, so I will not go into it in detail. Now if best time complexity is asked, what do you think best time complexity will be in this case? Here, if you try to figure out best time complexity, if it is sorted, best time complexity is that array is already sorted. If array is already sorted, will the swap function ever execute? If array is already sorted, swap function will not execute. It will just perform this. It will just go through these for loops and go through the if condition. That's it. But it will never execute the swap statement as well. So what will be the best complexity, how it works? If you want to know more about it, it is n, which is the best time complexity. But I will not be going through best time complexities in detail. If you want to calculate, it is n, but I will not go through best time complexities in details, because most of the times in interviews it's not needed. But if you are interested in learning it, you can go through learning it at any time. So this is your first algorithm, that is bubble sort. Now let's go ahead from bubble sort to the next most common one we use, that is selection sort. So I have a question, that is there any relationship between worst case to best case? There is no, it's no, not the case, because it depends on the program. It's not guaranteed like that. It purely depends on the program. So the next sorting algorithm we'll go through is called selection sort. So if you go to code of selection sort, it's something like this. This also has two loops, but let us try to understand what happens here. See, here you are finding the smallest element and swapping it the first. Then you're finding second smallest element, you're swapping with the second. Then you're finding third smallest element, swapping it to third position. Fourth smallest element, swapping it to fourth position. Then just one is left. So it's just like bubble sort, whereas bubble sort you used to swap one value at a time, but here if there are 5 elements, I'll open this again. Here you have 5 elements. It will search for the smallest of the 5. That smallest element will be taken into first. Then search smallest of 4. That smallest is taken into second. Then search smallest of 3. That is taken into third index. Smallest of 4. That is taken into fourth index. Fifth you don't have to search. This is the whole concept of selection sort. So we'll go for the coding of this and see how exactly it works. Now, I'm not going to explain this in detail because I'm not going to go through the code of this entirely. But if you guys go through this, you see that throughout the for loop, we are trying to find the minimum value in the unsorted array. So what we're doing is, throughout this, whichever we find is minimum, whichever index we found as minimum, we're going to swap that minimum index with the first value. Then second case, we're going to swap that minimum index with the second value, and then third value, and so on. This is your whole code for this. Now, if you try this out, uh, I think I have to just scroll down a little more. Perfect. So now, let's say you go through this. This is your entire sorting, selection sort. What will be your worst time complexity? Can you guys figure out and let me know? So I have a question by the time. Does selection sort have any other name like this? No. See, insertion sort, bubble sort, we call it a sinking sort. But selection sort, we don't have any other name like that which we use. we just call it as selection sort only. So for every pass, the minimum most value is taken to the leftmost case. So what will be, let's say, the worst time complexity here? The question to you guys is this: for selection sort, what will be the worst time complexity? So if you perform the number of steps, see, you guys need to know, if you go through this code, I will try to explain this in detail. See, there are multiple passes that you will go through here. First, to do this, I'm gonna just take some empty space to explain this clearly to you guys. See, if your array is something like 50, 40, 30, 20, and 10. In the first case, you're gonna have to do n minus 1 comparisons. In the first case, it is n minus 1 comparisons in total. That is, you're gonna compare these two, whichever is smallest. 40 is smallest. Since 40 is smallest, you're gonna compare these two. Here 30 is smallest. Since 30 is smallest, you're gonna compare these two. Now 20 is smallest. Since this is the smallest value, you're gonna compare the next value with this. So by doing 1, 2, 3, 4, 4 comparisons, you're able to find out that the smallest value is 10. So once you found it out, you're gonna swap 10 with the value that is 50, and then make it like 10, 40, 30, 20, and 50. Now first index will have the smallest value, that is done. Now you have 4 more. So you're gonna do comparison with these two. 30 is the smallest. So you're gonna compare these two. Now 20 is the smallest. You're gonna compare these two. Now 20 itself is the smallest. Since 20 is the smallest, we're gonna swap these two. So number of comparisons we essentially did were 1, 2, and 3. So here we are gonna do n minus 2 comparisons. So that will result us with 10, 20, 30, 40, 50. Even though it is already sorted, you're gonna do 2 comparisons over here, which is n minus 3, and in the next case you're gonna do 1 comparison over here, which is n minus 4, and so on. So if you try doing this, there are totally you have to do this entire n minus 1 times. So this entire pass you have to do n minus 1 times. 1 time, 2 times, 3 times, and 4 times. You're doing this n minus 1 times entirely. So first part is n minus 1. And that is again, every time you're going to keep doing with a different value. That is, you're going to do 1 time as n minus 1 times, then n minus 2, then n minus 3, and so on. So if you calculate it and try working it through, if you calculate it using what is called master theorem or recurrence relations, the t of n obtained for it will be n into n minus 1 by 2. If you're interested, what is t of n, how do we calculate this and everything, try going through recurrence relations and master theorem. That will help you understand this very clearly. But if we just look at our code for us, for our case, we know that there are 2 loops. One goes through n minus 1 times, another one goes through n times. So we just calculate it as n minus 1 into n, which is almost n into n, which is n squared times. And your entire case here, entire time complexity, will be n square. That is to say, in short. So if we copy this, again here also big O of n square. They may also ask a theory question based on this. Which is the best sorting method among the following? They may give 2 or 3 options, and they may ask you which is the best sorting method of the following. So you will need to learn how to solve those questions as well. So anyway, we'll try looking at that further on. Now, going ahead from these sorting, the next sort we will look at is insertion sort. Now, this is your entire code for insertion sort to begin with. I'll just take this and I'll close the selection sort. We don't need that. So in the insertion sort, when you begin with this, your entire code is something like this. Now, how long does it take, or what is the case that happens here? To understand this, you need to just observe first. I'm just going to give you guys a GIF of this. I'm going to show the GIF just to show you how exactly it works. So just observe this for a minute. Try going through this. You'll get to understand that it is somewhat similar to how do I say, bubble sort and selection sort both. And when you start going through many sorting algorithms together, you'll start getting confused that which one is which and so on. So because of that, we won't be able to go through every sorting algorithm together. So here's essentially what you're doing. So you're taking a value, you're searching with all its previous values, checking if it is lesser, greater than, whatever it is, and you're trying to sort it in its place accordingly. Okay, same as playing cards. Okay, you can say that. You can say that in a certain way. So this is your simple explanation of how insertion sort works. You take one element, you try comparing it with all the elements before it to try where you have to go through. You guys want to see this once more? See, look at this. You're starting with the first element. So merge sort, yes, to answer the question, yes, merge sort does follow divide and conquer. We will see how to solve it further on. So in insertion sort, uh, in this case, first three elements are sorted. You're taking fourth element and you're inserting that fourth element in the sorted first three element array. Once that is done, now you're taking the fifth element and you're inserting in the sorted array. It's already largest, so it goes there. When you take 7, you insert it again in the already sorted array in the last second value. Then you take 2, you try to figure out where to insert it in the already sorted array. That is right after 1. So you go ahead and insert it over there. Now, at last, you're taking 4 and you're going to sort it over there. Now, if you look at this, you can immediately see that its time complexity is really bad because it is efficient on small values, but when the values are large, it does not work well with it. So to answer a question, yes, it only checks with the elements before it, which are already sorted, to explain in short. So here's what you're doing. If you want to go through the entire insertion sort algorithm, you can go through that. But I will not be explaining the algorithm for now, because if we start going through algorithm and everything, it's going to take much longer time. I want us to go through the time complexities more, because that is the first thing they will ask. So let's go for this. I just want you guys to go through this and let me know, what do you think will be the possible time complexity here? I've got one answer as log n. All right. Any other answers? It can't be log n unless you are performing divide and conquer. See, when you say divide and conquer, you're going to divide it and conquer half of it completely. That is divide and conquer. Here, what you're doing here is you're taking the first and second value, sorting them. Then you're taking first two with the third value, sorting them. Then you're taking first three with the fourth value and sorting them. So it's pretty much like in previous case, you are taking n values and comparing n minus 1. Then you are taking n minus 1 values and comparing them. Then you took n minus 2 and compared them. Then n minus 3 and compared them. Then n minus 4, n minus 5. In this case, it is the very opposite. You're comparing 2, then 3, then 4, then 5, then 6. It's just the opposite order of what you did before. So this also is big O of n square. The order of comparison is exactly same as previous case, but you're just doing it in the opposite order. So here it goes up to be big O of n square only. Think about this. You're just taking, if there are 5 values, first you're comparing first two, then you have to compare the third with the first two, then you have to compare the fourth with the first three, then you compare the fifth with the first four. In the previous case, if there were 5 values like bubble sort, you are comparing first 4, you're comparing all and putting the final value here, largest value. Then you're comparing first 3, put largest value here. Then you're comparing first 2, put largest value here. Then you're comparing first um, 2 here and putting largest value of them here. So there's no difference if you look at this. So its time complexity is also big O of n square. If you want to try calculating by giving a value, you can take an array and try calculating with this. You will be able to work through it. So this is one thing I would suggest you to give it a try. You can take the same case with one example and try it out. So going ahead from here, let's go for the next part. In this case, yeah, most often they will only ask worst time complexity, correct? Most often that is the case. So going ahead from these three, see, these three are the ones which take bubble sort, selection sort, and insertion sort. I wanted to explain them together because their how do I say, sorting time is also similar. Now that we understood these three, we're gonna go through a very different kind of algorithm up next. We have the other three, that is heap sort, merge sort, and quick sort. These three are the other kinds of sorting algorithms that you may expect the question in. So let's go through heap sort first. If you look at this heap sort, it is you'll observe this, you'll be able to understand it better. First, go through this. First, observe the entire sorting method. You'll be able to understand it much better once you observe this. So in a heap sort, you always have the entire array in a tree. And when it is in a tree, you keep storing them as binary search trees. Now, when you store 7 over here, the condition is that 7 cannot be to the right to below 3 because 3 is lesser than 7. Now, when you store 2 over there, 2 cannot be below 7 because you'll keep getting such conditions. To solve it one at a time, you'll understand it further on. Now, if you observe here, you will follow binary search tree methods over here. When you follow binary search tree methods, you'll be able to then, or not exactly binary search tree methods, something similar to that is what we can say in short. You'll be able to get it solved like this. Now, this may be very confusing for you right now. If it is confusing, don't worry. You can go through what is a binary search, what is heap sort, and how do you sort it, and so on. Just remember, once you get this, what you have to do is keep trying to sort it just like a binary search tree now. Just try to sort it like a binary search tree. You'll be able to get which value should be highest. So the point is to get the highest value as root. The point is always to get the highest value as the root. Once you get the highest value as the root, then you keep solving it based on binary search tree. So 5 is the highest value. Once 5 is the root, you will then see 1 and 4 are not in proper positions, change them. Now 5 and 2 are also not in proper position, change them. You got the highest value here, remove it. Now take the highest value to the root again. Once you have taken the highest value, see what is wrong. 4 is supposed to be here, 1 is supposed to be here, however it is, solve it. Now again, take the highest value to the root, try to solve inner subtrees, whatever is wrong. So here 1 is supposed to be root, so get this back and put it back here. Now in this it is correct. Again, as usual, take highest value to the root, then try to solve it as a binary search tree. Wherever it comes up, remove it. This is what you're left with. So whenever you get this, you have to first place the initial array as a tree. So always remember, binary tree or binary heap. Heap sorting is also called as a binary heap sorting. Remember that. So you're just storing them in a tree first. First, you're just starting to store them in a tree. Yeah, it is playing again. We are storing them in a tree. So in a tree, if you want, you can give direct conditions like this. But store everything in a tree. You can give direct conditions like if a root is, in this case, right value is lesser than, greater than root, put it above, and so on. So some conditions you can give at the start. Which conditions are there? If you start to go through that, it's going to take a huge amount of time. So once you do those minor conditions, you can Google it. First step is biggest value should be root. Always remember, biggest value should be the root. Once you put it up as a tree, you do a little pre-processing, a small amount of pre-processing in the tree by finding out whether its immediate left child, right child should be there or not, or it should be changed or not, or something. In the initial tree, bigger values should be above, smaller values should be below. That's the condition. After you make the tree, first thing, take the largest value as the root. After taking largest value as the root, try sorting this. Try sorting this as a binary tree. It was 1 and 3. It should be 3 and 1. Then try sorting it out as a binary search tree until you take the largest value at the end. Once you get the largest value at the end, see, now you have 6 and 1. Take the largest value at the end. Once you do that, your entire step here is done. So these are some simple statements. Again, if we go through the entire sorting of heap, it's going to take a lot of time for us to do that. You're going to need to learn all the rules of see, if it is confusing, I'll just write down the basic rules for you to go through later on. Will you guys try those rules? If I just write down the basic rules, can you at least go through the other ones? Yes, the previous ones are simpler. Yes, I understand, because those are the basic ones that we often go through and learn. Guys, please wait. I think I have an issue with my mouse here. Just hold on for a minute. All right, going back to this. So since you guys want me to just write down the basic rules, I'll just write in heap sort. Again, please note, if we want to learn heap sort, we're going to have to take a lot of time. Now, I don't want to take a lot of time to learn this. I want to take only time to show the, it's not necessary that one is important than the others. The most important, I would say, is merge sort and quick sort. Those are the most important ones, is what I would say. Now, here's what you need to do. First step, for every node I other than root, remember, I'm saying for every node I other than root, if value of I is greater than or equal to the value of its highest valued child, make I as parent node. So these rules, when you directly start with them, they are a little confusing. So you have two types of heap sorting as well. If you start with them, there is one heap sorting method called max heap sort, and there is one more called min heap sort. There are two of them. So again, if you want to go through entire heap sorting, we call this as a heapify function. We generally call it as the function in which you perform the sort as. heapify function where you send the entire array and which is the value you're supposed to send. So once you send the value to this, you're going to perform this sort of function. So if I want to write this in the shortest way possible, if I want to write it in an easier way possible, I'll just write for every non-root node I, for every non-root node, let's say it is I, all that you're doing is value of node I should be greater than or equal to its highest valued child. Remember, for every non-root node I, value of the node should be greater than or equal to its highest valued child. Now, if you observe the diagram, now when it starts storing here, observe this. This is max heap. Max heap is where value of node should be greater than or equal to its highest child. Is it greater than or equal to its highest child? No. So you swap it. So again, is it greater than or equal to its highest child? No. So swap it. So same way, you take n here. Is 3 greater than or equal to its highest child node? No. So swap it. This is the starting rule that you need to know. So when you put up 2 here, 7 is greater than 2, no need to swap it. When you put 1 over here, if you observe, when you put 4 over here, 1 is not greater than or equal to 4, so you swap it. 6 is greater than or equal to 4, so no need to swap it. These are the first basic steps you need to do. After this, then you sort it using this method. Then you sort it in this case. So again, if we go through this entire algorithm, it's going to take at least 1 to 1.5 hours for us. And this is not required for your program because they will not ask you to sort using heap. So instead, what we are going to do here is not exactly a prefix. It's a different way. You can try this out. You can figure out how to do this. So in every step, you try to take the highest value last. After taking highest value last, repeat the same steps, keep on doing it. Keep on doing these sort of steps to make it to a binary search tree. That is how you'll be able to sort this. So the first rules to make it a tree, these are the rule you need to know to make it a tree. After you make this a tree, then you call the heapify function to perform the analysis or to perform. Now, I will not go through the entire part. My entire thought here is just to go through the time complexity of heap sort. So we'll go through this whole algorithm that we have. Now, you have this as int largest equals I, then L is this much, R is this much. You have all these values. It is a complicated program. And to top it off, it is a recursive program. Then you have a recursive program to calculate your entire, how do I say, to calculate the entire complexity. You need to perform a lot of steps in this. So in short, I will just say, since we cannot go through and perform either recurrence relation or go through master theorem method or something like that, in short, just for you to understand as of now, I'll just state the worst time complexity for this. So this is the reason why I told you guys, we can't go through such big algorithms completely as of now. But since in pseudocode round, these are not often asked, you will not expect these questions. If you try it though with an example, since this is something like a divide and conquer, remember it is based on binary search tree. What is the worst time complexity of binary search tree? You guys remember? In binary search tree, if I want to search an element, what is the worst time complexity? Remember guys, binary search tree, if you have n here, every value left to n is lesser than n, every value right to n is greater than n. Remember binary search tree? Remember, Isn't binary search tree a divide and conquer method? Isn't binary search tree same as your binary search? Now, of course, I told you guys one more thing in binary search tree, why it could be big of n also. I explained that in the previous session. But we will consider this as log n, as we basically consider that we are storing it as arrays here. Ma, right, one of you have, I think one of you have unmuted. Please make sure you guys mute. I did not select that mute part. Just hold on, guys. All right, perfect. So going back to this, let's get back to this case. Make sure you guys, I don't think you guys can unmute yourself by now. I will ensure the option at the end of the session so that you guys can ask any question if required, since this is our last session. So if you calculate this, it's essentially here log n, which is repeated n times. It's essentially log n amount of work, which is repeated n times. So it is essentially n log n, which is lesser than n square. If you calculate this, this will be n log n totally, which is lesser than n square, which is for bubble sort, insertion sort, and selection sort. So you can say in short that this method, that is particularly merge sort, is better than, or sorry, heap sort in our case, is better than, not merge sort, sorry, heap sort is better than all the previous sorting algorithms we tried earlier. So this is the basic concept you guys need to know about this. Now, let us go ahead from heap sort. Now, to the next one, I'm going to take the next one that is most important again, a pretty important. Now, merge sort. Now, if you try to go through merge sort first, again, we can't go through entire function immediately as of now, because again, we won't be able to have enough time to go through that. So again, I think this was this for merge sort? No, this was for selection sort. I'll just write the one for merge sort, which is n log n. Now, after merge sort, so, not merge sort, heap sort, after heap sort, let us now go for merge sort. I'm just going to show you guys the GIF of merge sort. Go through this for a minute, then I will explain what exactly happens here. Merge sort is proper divide and conquer. So you're dividing your entire array into n arrays of some amount of elements, and you're going to sort those arrays. So we're dividing into 4 arrays of 2 elements each. You're going to sort those arrays of 2 elements each first. Now go through this for a while. Once you'll be able to understand. Then take those each array of 2 elements, combine it as one array of 4 elements and sort it. Then do the same for the other one. Then combine them and sort it. This is your basic idea of, and once you've sorted them, you're going to merge the sorted arrays and sort them together later on. So guys, going back to this, if you guys are able to understand this, this is the basic concept of how merge sort works. Now, if you try to calculate how long it takes, again, for these sort of programs, you're gonna need to go through them entirely. This is not just like insertion or selection sort where you can just be like, okay, I know how many loops are there, I'm just gonna calculate it. It's not like that. you're gonna have to solve this entirely and then be able to identify. If you try this out at the end, this will also be n log n as well. This will also be exactly n log n. So why exactly it is n log n? It is always easy to go through that and try understanding it, try sorting it out by going through the program once, going through the algorithm once, one step at a time, and trying to sort it by yourself. See, it is not just log n, it is log n again repeated almost n times itself. So this also becomes n log n itself. So even though it is divide and conquer, you're dividing and conquering about n times. So n log n is repeated n times. That is why it is same as n log n. If it were just one time that you're dividing and just doing one part of the array, then yes, it is log n. But here it's not just one time. So you'll be able to understand why this is n log n in a merge sort. So similar to merge sort, if you really are interested in learning more about algorithms, there are things like, particularly in algorithms part, I'll just explain this. There are things like greedy algorithms. Then there are things like backtracking algorithms, where you have problems like n queen problems and so on. These are most probably not asked, but I'm just stating to you guys, if you are interested in learning this before the sessions tomorrow, it'll be good to learn it. Then followed by this, you have divide and conquer algorithms. There are so many types of algorithms. If you're interested, go through those algorithms like Floyd, Warshall's algorithm, Kruskal's algorithm. There are so many. But if you try merge sort, it is n log n by default, because you're essentially dividing and conquering, yes, but you're dividing and conquering n times in total. So you have a combined phase separately and you have a sort phase. Yes, there is dynamic algorithm as well. So if you want to know how exactly it is n log n, you have to learn this thing called master theorem. Remember, without master theorem, you cannot solve these. You have to learn these. So if you learn master theorem, which comes up with an equation like something like T of n, for this T of n will be something equal to 2 times T of n by 2 plus n minus 1, because one step is going to be lesser because you're doing n minus 1 times. Last value you're not supposed to. So this T of n by 2 will pretty much become log n and perform the whole thing. So merge sort also is basically n log n itself. Again, I'm stating this that I'm not explaining the entire algorithm. I will not be going through that. I'm just going through this in short, just to explain what will be the time complexity. For the time complexity of bubble sort, selection sort, insertion sort, we can do it right here, right away. But for others, you cannot. Then followed by this, you have one more algorithm called quick sort. Now, quick sort method is again, it's also a divide and conquer method only. Here, you recursively sort two subarrays, or you recursively keep sorting two smaller arrays of a single array. That is the basic point. Now, even if we just look at this, it is difficult to understand right away, because in quicksort, we're going to create a partition. So, okay, I have a question. What is a pivot element in this? In this pivot element here is, you have, yes, we generally choose rightmost element. We take that up and we call that as a pivot element. Or however, in this case, let me explain this in short. You select an element as a pivot element and you partition one sorted array and another partition unsorted array. You take values from that unsorted array and keep putting up to the left and sort it. Again, it is difficult for us to understand and explain this in a minute or two. But just remember, you have two arrays here. One is a sorted subarray, another one is an unsorted subarray. You're going to take this unsorted subarray and take one element at a time and keep putting it in the sorted subarray. So that is your entire method to do it. Now this is also done by dividing and conquering itself. So when you try calculating this, the value you get over here is also equal to big O of n log n. So these first three algorithms we saw are big O of log n. The last three algorithms you see, that is including quicksort, are big O of n log n. Now, apart from this, there are some other questions you guys may expect. I'm gonna just write down the answers for them in theory kind of questions that you guys may expect. I'll just answer the same for you guys. Now, going ahead, I have one more question. Which is the fastest sorting algorithm? Which is the quickest sorting algorithm? Do you guys know it? I'm getting one answer as quick because in the question there is quick. I'm getting one other answer as merge. So if you try calculating it, it's exactly quick. The fastest sorting algorithm is quick. Given its best case, worst case, and average case, quicksort is the fastest recursive sorting algorithm. Then comes merge sort as a close second. So if you go for the slowest sorting algorithm out of all of these, between quick, merge, and heap sort is the slowest of all of these. Remember this. Heap sort is the slowest, quick sort is the fastest out of these three. So going ahead from this, there are some other questions that you may expect. That is, slowest of all 60, these are very similar. Bubble sort, insertion sort, selection sort, both pretty much come up to be equal. We saw how they are almost equal. So they go through same amount of, how do I say, comparisons. They go through same amount of comparisons. You can try them out and see that number of comparisons are exactly same. So going ahead from this, there are some other sorts which you may not need to know, but if it is asked in interview, that is, which is worst time complexity of something like bucket sort or radix sort. I will not go even through the any gives or anything. I'm just going to explain how these work. Then you have shell sort. I don't expect anything else apart from these. So I will not explain anything else apart from these in terms of complexities. Bucket sort, you'll get something like big O of n plus k, and k value is also huge. That is why we use it as n plus, this is bucket sort we are talking about. That is n square bucket sort. And radix sort is where you have big O of n multiplied by a variable k, where k is also huge. That is why we take it exactly as nk. And if you try shell sort, it is entirely different. That is big O of, this is entirely different, n log n whole square. That is n log n whole square. There are a few more algorithms which also do the job within n log n sorting. That is that one of them is also team sort. I don't think you guys would have ever heard of this, but team sort also does the same job in big O of log n. You won't expect these according to me, because let's face it, they're going for all branches. They're not going for only computer science. Even if it's only computer science, I doubt you would expect all these. But just if you want, knowing this is not a harm. So these are some that you can expect as well. Now, apart from this, if you guys have any questions, you guys can put it on chat. I will also share a few more time complexity programs by then for you guys to try it out. I'll share just a few time complexity programs. Just make sure you guys also learn how space complexity problems work. We haven't done it a lot, but in case if it is asked, just make sure you're able to go through those as well. So by the time, if you guys have any questions, you guys can feel free to ask. By the time, I'll just provide a few programs for you guys just to try it out by yourself. So I have one question, that is how many theory questions will there be asked? You can expect somewhere around 10 at maximum. See guys, remember again, you're gonna have 30 questions in total. It's gonna be combined with C, C++, data structures and algorithms, and theory can be from anything. Theory can be from any of these. The theory questions can be from C, can be from C++. The theory questions can be from something like what else? Object-oriented programming as well. Or the theory questions can be from data structures and algorithms as well. Theory questions can be from any of these. So when it comes to graphs, worst case, you may expect one question at maximum from graph. So if you just know basic concepts of graph, that will help. Just basic concept of graph at least. So what I would state is, I have one more question. What is the suggestion? Do we, since we have exam from tomorrow, can we just go through these, or do you want us to go through more? See, we have gone through a lot of examples here. A lot. I'm not sure. We have gone through at least hundreds of examples, if I'm not wrong. I'm pretty sure about that. Now, especially in all of this. So what I would suggest you guys to go through is, see, these are all many problems we have based on time complexity and everything. If you're confident on what we have solved, go through more few concepts and interview questions, especially in OOPS, go through some concepts particularly on polymorphism. What kind of polymorphisms are there? What happens in which kind of polymorphism? In what kind of inheritance? What exactly happens? In public inheritance, what happens? Private inheritance, what happens? And in case of abstract classes, what happens? In case of interfaces, what happens? So you may expect some interview questions, basic theory on OOPS based on them. If you learn at least those, that will help you out. At least. So if you can learn them, go through them. My suggestion is, guys, you can't say that going through just one book or one content will be enough, because you may expect anything from anywhere. Now, apart from this, the other thing that you can expect is, even when it comes to basics of C, I'll just tell you guys, even if you go to very basics of C only, you can expect a few theory questions that is related to compilation or related to execution within C. So my suggestion, go through those um, basic concepts of how all of these work. But again, since it's last moment, it's very difficult to go through everything. Try going through everything we have solved, because those are most important questions that you can possibly expect. Apart from whatever we have solved, I'm going to list a few things that I want you guys to go through particularly, because those are some kind of questions that I think could pretty much be expected. So I have a question that is, tomorrow morning we won't be having classes. Make sure you revise as much as possible by tonight and tomorrow. Any questions, you guys have the Telegram group, you can always um, like ask, share the same. So cheat sheet, okay, I forgot to share the cheat sheet. I'll just search the cheat sheet somewhere in order to share the same to you guys. Just hold on for a minute. Having a cheat sheet always helps for time complexity, because you can't go through everything in short. So you have this website that is bigocheatsheet.com. I would suggest go through this. This is really good. You can get the entire cheat sheet of everything here. Yeah, also one more thing we haven't done, hash table, guys. Please go through hash table. What is hash as well? See, to understand what is hash, uh, if I give employees, let's say we have a company full of like employee numbers. If I give employees numbers from 0 up to 9999 randomly, one at a time. So one person gets 0, one person gets 9,000 and everyone. So there will be a lot of spaces wasted in between. So to make sure such spaces are not wasted, we do something called hashing where one person gets 1,000, one person gets 1,250, 345, 1,000 gets 7,890 or something. And this employee ID, whenever you want to read them, you're going to hash them. You will perform a hash function of 1,000 and you will get another number. Generally, it is performed by some mathematical operations like mod 10 into 5 or something like that to get a smaller unique value. That smaller unique value for 1,000 maybe 10, for 1,345 maybe 13, for 7,890 maybe let's say 76. So as long as there are 100 values at maximum, I can have 2-digit values in hash. So I don't have to waste 10,000 spaces. I can only waste 100 spaces. Once it crosses 100, I have to increase this again. I have to change the hash function. I have to change it to 3-digit values and so on. So that is your basic concept of hashing. So even in hash table, you may expect for search, it is only big of 1 because you know the hash value. If you have the employee ID, you can directly calculate hash value and search. That is only one operation. You're not doing 10 or 20 operations. So like this, you can expect when you're searching for something, you may have to do big of n because when you're searching for this, if you take this value, perform the hash of it, you'll get 76. If you're searching linearly, you'll get 76 at the last. So you've done all three comparisons. So total n comparisons. That is why it is big of n. So I have one question now. When it is insertion sort, radix sort, binary sort, and everything, which is suggested, linked list or um, sorry, the question is which is suggested, linked list or arrays? Linked lists are not suitable for which one? See, binary sort. First, let's go again. You have all of these sorting as well. So this is a really good website, guys. You guys can try these out. I think bigocheatsheet.com. I'll just share this. This one thing is enough. So I have one question. In sorting, in which sorting is linked list not suitable? So if you observe this, can you do linked list with insertion sort easily? Because when you do insertion sort, observe this. In insertion sort, worst case scenario is big of n square. Right, see, they're also giving worst case scenario of quick sort as big of n square. Do not worry about that in this case. Don't worry about that. Okay, just know that it is big of n log n itself. The reason why it's big of n square is if you try recurrence method and go through it, you'll understand. But don't worry about that for now. So when you do radix sort, you're not doing so much swapping. When you do insertion sort, selection sort, or bubble sort, you're going to do a lot of swapping. So when you do a lot of swapping, it's not easy to use linked list. So you should not use linked list in all these three particularly. So I hope that answers your question, because it's not very easy. Whereas in this case, radix sort, every time it's the same thing. But in insertion, bubble, and selection sort, worst case scenario is a lot when you use linked list. So you should know. Basically, you should know. So I have one more question about sharing. All right, I'll share the same over here. Like everything done till here. I'm just gonna share this. Now, by the time I share this, I have one more thing for you guys to share. Guys, before we end the session, I just want to share this one feedback link. Please go through it, guys, and share your feedback of our 20 hours of Capgemini specific training. How was it? Did you guys feel it was good, or it was worth it or not worth it? Whatever you guys felt like, you guys can share the same. So that will be really beneficial for me. It's personal feedback towards me. So you guys can open up about how it was, and you guys can share your feedback to me. So make sure I request all of you guys to share your feedback within that, within the link I've just shared. Now, going ahead from this, I'm also sharing the content of all the sessions from the start till today that we have taken up, which is pretty much somewhere around nearly 2000 lines of content. So I've just shared that as well. You guys can go through that as well. So anyway, going ahead from here. Now, before we end our session, I want to tell you guys a couple of important things, and I want to ask you guys a couple of things as well. See, when you go through DS or C++ or C, any time complexity problem, if you feel that it is too difficult to solve, if you feel it takes a lot of time, solve others first. Solve every theory question and every simple questions first, because the more you get correct, the better it is, instead of trying to go through only one problem to get it correct. Whichever problem you think is going to take a little longer time, leave it for the end. Do not solve it at the start, leave it for the end and try solving it at the end. If you don't know, mark anything by the end. This is first suggestion. Second, use elimination method. Whenever you don't know the answer, don't just randomly select one. Figure out which will not be the answer. Don't just randomly select one of the answer. Figure out which won't be the answer. If it is something based on, how do I say? Let's say if it's something based on time complexity, and the moment you look at the loop, you really are not able to understand, look at the options. If the option has log n, but in the loop you're not doing any divide and conquer, eliminate that option and choose one of the other three. So if you don't know the answer, don't just mark randomly, at least eliminate one value. If you eliminate one answer, instead of 25% chance of getting it correct, you have 33 or 50% chance of getting it correct, which is much better. So that is the second thing I would suggest. So go through as much as possible, guys. And you guys, everyone who are there in the Telegram groups, once the test is done yesterday, please make sure you guys just share how it was, what questions were asked, and what questions were particularly asked for you. If you remember or if you have written it down, uh, just share it. If you find it too difficult to type it and share it, just share it as a voice note. So it'll be helpful to try it out as well. So for more theory questions, if you guys want more theory questions, you guys have a lot of websites to get theory questions from. Just try oops interview questions. Just search for oops interview questions. You get lots of such basic questions. But my suggestion would be go through Sand Foundry. In Sand Foundry, you have this object-oriented programming as a separate part. Here you have all of these. So of course, some of them are not theory questions. There will be programs as well, but you can get a lot of theory questions here. Whichever topic you think is kind of difficult, you can go through them. Apart from everything we have gone through, because we have also gone through hundreds of such topics. So go through these, guys. I'm also going to share in the chat which websites you guys can go through. Yeah, I'm pretty sure you can work on the paper during the test. Yes. So you have Sand Foundry, you have Geeks for Geeks, and you have IndiaBex. These are a few common websites. You guys can go through them. So we're gonna end our session today, guys. But before we do that, two very important things. We will let you know. We are not entirely sure yet. Possibly TCS will probably think of. We'll let you know at Rohit. Will because TCS is particularly different than this. We're probably gonna look for TCS. We'll definitely confirm and let you know. So anyway, moving ahead from this, guys. Before ending, couple of important things. Uh, we'll confirm. Kushal, I'll just confirm. I'm not entirely sure. We'll confirm. So before ending this session, guys, just know that everything you have studied in 20 hours is a lot of concepts. But then again, that doesn't mean that whatever you have learned, that itself will come up in interview. So keep working, keep trying hard, keep learning as much as possible. Good luck with all the rounds ahead. Let me know how it turns out. Just use the Telegram, DM me. If you don't want to put it in group, DM me. And if you keep forgetting those questions, just you don't have to type. You don't have to go through the struggle of typing them. Just send them as a voice note. That is enough. I'll be able to at least go through them then. So make sure you guys do that without a doubt once the entire test has ended. Good luck, guys. Study. Don't panic. Most importantly, don't panic, because you guys panicked a lot at the start when we tried out these functions, and you guys gave the wrong answers even though you knew the basics. Once we solved it, then you were like, oh, this is how it works. So don't panic. Go through one line at a time, one step at a time, very clearly. Try and understand it. So give this a try, guys. Try it out. um, at Umashankar, I'm not entirely sure about that. I'm not entirely sure. But going apart from that, make sure you guys go through all of these things as much as possible. Try working it out. And if you do get the technical or HR round tomorrow itself, just at least know a little bit basics of your project. Just basics. What you're doing, what the project is on, and just basics of mechanic, machine learning and all that stuff. After all the rounds are done, if it is announced. If not, if it is further on some other time, then chill, don't worry. But go ahead with this, guys. Thanks for the nice feedback. I'm happy to hear such a nice feedback. I'm really happy that you feel like all the minutes spent here are worth it. I'm happy to hear that. So we'll stop here, guys. Good luck. I hope you guys do well. And once you finish the test, please make sure you guys, without a doubt, just ping me up. Ping me up and let me know what questions were asked, how was it, particularly in pseudocode, whichever question you remember, just say that question out to me. That will be enough. At least I'll also be able to go through who gets what sort of questions and everything. That will make it easier as well. All right, guys, so we'll stop here. Have a good time. Study well, learn as much as possible. Don't panic. Solve the easiest ones first, then go for the other ones with elimination method. Good luck, guys. Have a good time. Let's catch up tomorrow over text. Take care, guys.